Now let us simplify this and write down equation in the form of I1 and I2. So you can see minus 4 minus 1 will be minus 5. I'll call it 5I1. Then we have minus of minus I2, which is plus I2. I'll call it minus I2 because I'm taking first term as positive. So we have got I1 term, I2 term, and plus 20 minus 12 will be equal to plus 8. That I'll be writing on the other side. So this is my first equation that I've got. I repeat, minus 4 minus 1 is minus 5. I'll send it on the other side. It will become plus 5I1. Minus plus I2, send it on the other side, becomes minus I2. Minus 12 plus 20, I keep on the same side, which is 8. So this is my first equation. I call it equation number 1. Let us now apply KVL in the second loop. Applying KVL in mesh 2. Mesh 2 is nothing but this particular mesh. We will again travel in clockwise direction. Let us first start from this 2 ohm resistance. Clockwise direction would mean that I'm traveling in the upward direction through this 2 ohm resistance. So traveling in upward direction, the polarity of the voltage across 2 ohm resistance will be plus here, minus here. So there will be a fall in voltage. And once again, applying that simple rule, whenever we travel in the direction of current, the drop will be negative. So the first term that we get will be minus 2I2. Next we come across resistance 1 ohm. Let us see what is the voltage across 1 ohm. We had already written voltage across 1 ohm in the previous KVL. If we want, we can take the same term in the second KVL, or you can redefine the voltage across 1 ohm. Let's do that. Let's redefine the voltage across 1 ohm resistance. This time the original current directions will be same. That means I1 flows towards left, I2 flows towards right. This time, because we are writing KVL with respect to I2, let us say that I want to get current which is flowing towards right through 1 ohm resistance. So what will be current that will be flowing towards right? The difference between the currents is I1 minus I2 or I2 minus I1. Now the current which is flowing towards right will have the same direction as I2, and hence this time the equivalent current we will call it I2 minus I1. So what will be the new potential or new voltage drop across 1 ohm? Current flowing towards right will give us the drop as plus minus, so fall in voltage again, it will be minus 1 into this time I2 minus I1. Next is resistance 3 ohm, which is again having two currents, I2 as well as I3. So if I quickly just consider this 3 ohm resistance, you can see current I2 is flowing in downward direction through 3 ohm like this, and current I3 is flowing in upward direction like this. So equivalent current I will consider having the same direction as I2. So let us say equivalent current is flowing in downward direction. So what will be the value of this? It will be nothing but I2 minus I3. The difference between I2 and I3 in the downward direction will be I2 minus I3. So once again, because we are traveling in the clockwise direction, we are in the same direction as I2 minus I3. So the drop will be negative and it will be equal to resistance, which is 3 into I2 minus I3. Next we come across this 25 ohm. We are traveling in clockwise direction, so we'll be going towards left. From negative polarity to positive polarity, drop will be positive, so it will be plus 25 equal to 0. So that's my second equation, but we need to simplify this. There are all the three currents appearing this time, I1, I2 and I3. So the first term is for I1, minus plus I1. I2 we have minus 2 here, minus 1 here and minus 3 here. So that will make it minus 6 I2. And for I3 we have minus plus 3 I3 is equal to, I'll send this plus 25 on the other side, it will become minus 25. This becomes my second equation.